Hey, it's Coach Ash. Let's see how do we use Desmos to actually calculate the normal distribution probabilities and also the z-score probabilities. It's so much easier than using a calculator, and I would highly suggest you use it. So let's start. There are a lot of words here, but basically what they're saying is it's normally distributed around 22.7, and then the deviation is 1.4. So what this means is the mu is equal to 22.7, and then the sigma is equal to 1.4. And we're going to look at the Desmos soon. We just need to calculate this. The z-score associated with 23s, as you know, the z-score is equal to x minus mu over sigma. So let's calculate that real quick. This is 23 minus 22.7 over 1.4. So whatever this is zero point 0.3 over 1.4, which is this number. Now let's look at the next question. So how many cars would be expected to get above 23? As you know, is the mountain curve, right? Is the normal distribution curve here. So what you need is you're basically going to look at this particular part here. This is the mean, which is 23, and then you want to calculate my bad, the mean is 22.7 here, and then you've got a standard deviation, etc., right, which is 1.4. So there are two ways to do this. Either you can do it this way, or you can use the z-score and you're going to get it. So let's try the basic method first. So you've got 23 here, right, and then the mean is 22.7 and 1.4. So what I've done is I've just already written down 22.7, 1.4, which is the mean over here, and then the standard deviation, and then this is just greater than 23, and this goes to infinity, right? It just goes to infinity. How easy is that? And then the z-score is going to be 0, 1, right, which is the mean, and 1, and then you've got this answer, which was our original z-score, which was 0.3 divided by 1.4. So how do you get all of this? So we can try the step here. So the first thing you want to do is you want to let's go over here and do functions, and then under functions you're going to go to distribution. So it's way down here, right over here after visualizations is distribution, and then you put norm dist here, right? And then the first thing you want to do is what's the mean, and this I'm just putting this again here, the same thing, 22.7 comma 1.4, which was in our original problem right here, right? This was it here, the mean 22.7, and then the standard deviation is 1.4. Now you click on this cumulative probability, and then all you need to do is you want to say that the x is greater than 23, right? My bad, it's right here. So you put 23 because they're saying what is greater, and you see this automatically, this probability is greater than this infinity comes up over here, which is the answer. If you feel like it, you can still put 99999 if you want, or just leave it the way it is, and there you go, you got your z-score. So how easy is that, right? Super easy. Now this is without the z-score, I mean. Now with the z-score, what do you do? So this was originally without the z-score, right? This value here, which I've calculated, is the same answer because I'm just showing it to you. Now let's try to do the z-score. So remember the z-score was, how much was it? It was 0.3 divided by 1.4 in the earlier example right here. Right, this was 0.3 divided by 1.4. So let's just plug that inside the Desmos calculator. How super easy. Again, let's practice this. You go to functions, you scroll down, you search for it. It's here, distributions, normal dist, and this time, because it's a z-score, just put 0, 1. Then cumulative probability, you want to put in here, what do you put in? Instead of 23, you're going to put in that z-score that you calculated, and that z-score, you don't even have to put in the decimal form of it, right? You just put in just a fraction, which is the cool part about this. I really like it this way. And it gives you the precise answer, which is 0.415. You see this value here, this part here, using the normal distribution and using this z-score is the same answer, 0.415. So that's how easy it is. Let's look at a few more problems. Let's do it both ways. How many would get between 21 and 24? So again, is the mountain curve the normal curve? The average is 22.7. You kind of like want to visualize this, right? It's between 21 and 24. So this is 21 here and 24. So let's calculate the z-scores first before we move on. So what's the z-score? Z-score is always x minus mu over sigma, right? That's the z-score. So how would you find the 21 corresponding z-score for 21? So you're going to do 21 minus 22.7, which is here the mean, right? Always you do this the way, divided by 1.4. And you don't even need to actually calculate the entire thing. What is it? This is equal to negative 1.7 divided by 1.4. Whatever this number is, let's just leave it like this. Negative 1.7 divided by 1.4. And then 24, how would you do that? The z-score is going to be 24 minus the mean, which is this, using this formula again, divided by 1.4, which is 1.3 divided by 1.4. You can calculate this, but this is what we need. That's all we need. So remember, we have these two values, negative 1.7 divided by 1.4 and 1.3 divided by 1.4. Let's go to Desmos now. Your memory is probably stronger than mine. What were the numbers here? Negative 1.7, and then this was 1.3 divided by 1.4, and that's the answer here. Let's ignore this part and let's move it here. So this was the z-score style, right? And this one is 22.7 and 1.4 is already the mean, and all you need to put in here is, what were the numbers here? I've got the memory of a goldfish, so let me go back and check it. It was between 21 and 24. So you just put in 21 here and 24 here. The purpose of showing this to you is that the answers are the same, and these are the answers: 0.711, 0.711, 711. There, there you go. All right, the next one. C is done. Let's go for D. All right, D and E. Let's look at these. So D is like the stepping stone for E. So how many standard deviations from the mean? How many standard deviations from the mean would the car be this? This is just another way to say this is just the same way, meaning as z-score. So what's the z-score? The z is equal to x minus mu over sigma. So what is the x here? This raw score, right? It's 17.2 minus the mean we know is 22.7 over the what is it, 1.4. So let's calculate that, and let's leave it as, let's be professional, let's be cool, and let's just leave it like a number, negative 5.5 divided by 1.4, right? Whatever this number is divided by 1.4 for the sticklers, this number is negative 3.9286. Whatever. I'm going to use this number, and all you need to do now, this is the standard deviation, so this is way to the left, right? This part, if you have the curve here, this is the mean, and this is right here, negative 3.9, almost 4 standard deviations away. So it's very far. It's like a very low chance, right, of having this curve. But what we are doing here is, suppose you purchased a car, and then a typical salesman, right, a car salesman tells you that, oh, 17.2, which is extremely poor in our judgment. They say it's normal, it's just regular, right? Obviously this word is bad. It's just not a problem with this car, right? So, but you want to tell them the probability of having this score, this particular value, is so less. So how would you do it? So you want to show that the probability of it being 17.2 or less is extremely small. So what you want to do is, really, you want to show that what is the probability of this being less than 17.2 or less than this value, the z-score. So let's do that. So remember, the value is 17.2 or 5.5 over 1.4. This is the last problem. So we put 17.2 here, right? Because this is like our basic original normal distribution curve, and then just drop it. It automatically goes to negative infinity, and there you go. You have it. This is the real probability. And here, what was the number again? I think you will remember this better than me. It was negative 5.5 over 1.4. So I'm going to put this here. Where do you put it? You're going to put this here, negative 5.5 divided by 1.4. Just drop this and nothing, because this goes to negative infinity, means that value and anything below that. So you see these two check. The reason I'm doing this, both of these together, is just to show you that the z-score or the original distribution are both going to have the same probabilities, right? So the probability is 4.3 times 10 to the negative 15. Let's go to the salesman and whoop him. whoop, whoop his star star star. So what's the probability is extremely small. So this is how you will refute his claim by saying it's like 10 to the negative 5 that come on, right? The car is a lemon. So basically, this is how you do it. Remember the main idea one more time. How do you do the standard? How do you get to the? How do you get to this part? Is the really the only thing. Otherwise, it's easy. Go to functions here, right? How do you even get this? You go to this part here at the bottom, right? Let me just move this up here for your benefit. It's here. This thing at the bottom. You hit this, then you go to functions, and then you are gonna go to norm dist, and then put in anything you want. I mean, you click here, then go to functions, norm dist, and you have it. Excellent. So check out for more videos, and I will see you very soon. Have a nice day.